In 1961, the world exhaled after 3 quiet years of nuclear peace.
Полевой столб, поднимающийся с земли, быстро увеличился в объеме. Через несколько секунд после взрыва диаметр полевого столба составлял около 10 километров.
Then, with zero warning, the Soviets lit up the sky with a 50-megaton monster. It wasn't just a test, it was a message. And it forced the US to gamble everything on one nuclear launch from underwater. A launch that had never been done before and could have ended in total disaster. This is the test that changed nuclear strategy forever. For 3 years, the world had experienced something rare during the Cold War: relative peace when it came to nuclear weapons testing. Both the United States and Soviet Union had stopped exploding nuclear bombs since 1958. This informal agreement wasn't written down anywhere, but both superpowers respected it. The world felt a bit safer knowing that massive nuclear explosions weren't lighting up the atmosphere every few months. That peaceful period ended abruptly on August 30th, 1961. Soviet Premier Nikita Khrushchev announced that the Soviet Union would resume nuclear testing immediately. Within hours, they detonated their first nuclear weapon in 3 years at their Semipalatinsk test site in Kazakhstan. The explosion caught American intelligence completely off guard. Nobody in Washington expected the Soviets to break the testing pause so suddenly or dramatically. They resumed testing in September 1961 and culminated in the 50-megaton Tsar Bomba in October. This hydrogen bomb produced an explosion equivalent to 50 million tons of TNT, making it the largest nuclear weapon ever detonated by any country. The mushroom cloud rose 40 miles into the atmosphere, and the flash could be seen from 600 miles away. Soviet scientists had originally designed the bomb to produce 100 megatons, but they reduced its power because they feared the fallout would contaminate their own territory. American monitoring stations recorded the blasts as American intelligence agencies worked frantically to understand what the Soviets were actually testing. The information they gathered was alarming. The Soviets weren't just testing bigger bombs, they were developing entirely new types of nuclear weapons and delivery systems. Some tests appeared to focus on tactical nuclear weapons designed for battlefield use. Others seemed to test new warhead designs that could be mounted on intercontinental ballistic missiles. President John F. Kennedy found himself under intense pressure from military advisors. Defense Secretary Robert McNamara presented classified reports showing that Soviet nuclear capabilities had advanced significantly during the 3-year testing moratorium. These formal assessments gave Kennedy the justification he needed to consider resuming American testing. The Joint Chiefs of Staff argued that America needed to resume testing immediately to maintain nuclear superiority. The informal testing agreement that had kept nuclear explosions out of the headlines was now completely destroyed. Other nuclear powers began making their own calculations about whether to resume testing. The brief period of nuclear restraint that had characterized the late 1950s was over, replaced by a new arms race that threatened to spiral out of control. Kennedy faced a difficult decision. Resuming nuclear testing would likely trigger even more Soviet tests and potentially lead other nations to develop their own nuclear weapons. However, allowing the Soviets to gain a significant advantage in nuclear technology could shift the entire balance of the Cold War. In early 1962, Kennedy announced that the United States would conduct Operation Dominic, the largest nuclear testing program in American history. The operation would include 36 separate nuclear tests conducted across the Pacific Ocean. Unlike previous testing programs, Operation Dominic would test every type of nuclear delivery system America possessed, including some methods that had never been attempted with live nuclear warheads. America was about to undertake a testing program that would dwarf anything previously attempted. Planning Operation Dominic meant solving a puzzle that no military had ever faced before: The United States needed to move 28,000 military personnel and 200,000 tons of equipment across thousands of miles of Pacific Ocean to conduct 36 separate nuclear tests. In just 2 months, engineers built runways, igloos for warheads, and data labs on remote atolls. Every piece of equipment had to be shipped to islands that required massive infrastructure development. Christmas Island became the center of operations for the airdrop tests. The island sat 1,200 miles south of Honolulu and 120 miles above the equator. The British had conducted their own nuclear tests there from 1956 to 1958, leaving some basic infrastructure that American engineers could adapt and expand. Military engineers built upon these existing facilities while constructing additional support facilities, diagnostic stations, and secure storage areas for nuclear weapons. Johnston Island served as the launch site for the high-altitude tests, called Operation Fishbowl. This American territory was located 860 miles west-southwest of Hawaii. The island was much smaller than Christmas Island, which made construction even more challenging. Engineers had to create entirely new launch pads capable of firing rockets carrying nuclear warheads hundreds of miles into the upper atmosphere. The rockets would test how nuclear explosions affected the space around Earth. The Air Force used Barbers Point Naval Air Station in Hawaii as the main base for B-52 bombers. Scientists and engineers from weapons laboratories performed the final assembly of nuclear devices at Barbers Point. The assembled weapons were stored in secure igloos that were normally used for naval ammunition. Each nuclear device had to be carefully prepared and loaded onto aircraft for transport to the test sites. Scientific teams faced the complex job of setting up diagnostic equipment that could measure nuclear explosions accurately. Their main goal was to record what happened during the first moments of each detonation. They used optical detectors, electromagnetic sensors, and high-speed cameras that could capture events happening faster than the human eye could see. All of this equipment had to work perfectly in the harsh conditions of remote Pacific islands. The tests planned for Operation Dominic covered every method America had for delivering nuclear weapons. Some tests would drop bombs from aircraft flying at high altitude. Others would launch nuclear warheads on rockets into space. The program even included underwater explosions at depths of 650 feet. The variety meant that each test site needed different types of equipment and safety measures. Military planners worried about radiation exposure for the thousands of personnel involved in the tests. Previous nuclear testing programs had caused serious health problems for many participants. All B-52 drops were designed as air bursts rather than ground explosions to reduce radioactive contamination. Even with these precautions, the program faced significant risks from radiation exposure. Johnston Island presented unique challenges because of its small size and remote location. The island needed launch facilities capable of sending rockets 248 miles above Earth's surface. These high-altitude tests had never been attempted before with live nuclear warheads. The rockets had to work perfectly, or they could scatter radioactive material across the Pacific Ocean. By spring 1962, the massive construction and preparation effort was nearly complete. America had created nuclear testing facilities across the Pacific that could conduct experiments no country had ever attempted. But all of these elaborate preparations were designed to test America's existing nuclear weapon systems. The most important question remained unanswered about the weapon system that military strategists believed would define the future of nuclear warfare. That weapon system was the Polaris submarine-launched ballistic missile, and it promised to solve the fundamental problem that had plagued nuclear warfare since World War II. The nuclear weapons America had used since World War II all shared the same major weakness. Bombers carrying nuclear bombs could be tracked by radar and shot down by enemy fighters or anti-aircraft missiles. Land-based nuclear missiles sat in fixed locations that enemy intelligence could identify and target for destruction. Both delivery methods gave enemies the chance to see an attack coming and potentially stop it before the nuclear weapons reached their targets. Submarines changed everything about nuclear warfare strategy. A submarine could travel anywhere in the world's oceans without being detected by enemy forces, unlike bombers that appeared on radar screens or missile silos that could be photographed by spy satellites. Submarines remained completely hidden beneath the ocean surface. This invisibility meant that nuclear weapons launched from submarines were nearly impossible to intercept or prevent. The Polaris missile system represented a completely new approach to nuclear weapons delivery. Engineers designed the system specifically for submarines, creating missiles that could launch from underwater and fly hundreds of miles to hit targets on land. The missile used solid fuel instead of liquid fuel, which made it much safer to store aboard submarines for months at a time. Each Polaris submarine could carry 16 missiles, giving a single submarine the nuclear firepower to destroy multiple cities. Military planners had spent years developing the Polaris system, but they faced a critical problem. Earlier trials used inert test re-entry vehicles matching the warhead's weight and dimensions, but without fissile material. These test warheads helped engineers understand how the missiles flew and whether they could hit their targets accurately. However, the tests couldn't prove that real nuclear components would survive the launch process. The underwater launch environment created extreme conditions that had never been tested with live nuclear weapons. When a Polaris missile launched from a submarine, it traveled from underwater to surface in seconds under extreme acceleration as it shot from the water into the air. The nuclear warhead inside the missile faced intense vibrations, pressure changes, and temperature variations during this process. Nuclear weapons contain extremely delicate triggering mechanisms that must work perfectly to create a nuclear explosion. These components include precise timing circuits, explosive lenses, and radioactive materials arranged in specific patterns. Military engineers worried that the violent forces during submarine launch might damage these sensitive parts. A nuclear warhead that failed to explode properly would be completely useless in actual combat. The saltwater environment around submarines created additional concerns for nuclear weapon designers. Submarines operate in corrosive seawater that can damage metal components over time. The missile launch tubes had to protect nuclear warheads from moisture and salt exposure during long submarine patrols. Even small amounts of corrosion could potentially interfere with the nuclear weapon's ability to detonate. The success of the Polaris system would determine America's nuclear strategy for decades to come. If submarine-launched nuclear weapons worked reliably, America could maintain a nuclear deterrent that enemies couldn't destroy in a surprise attack. The only way to know whether the Polaris system actually worked was to conduct a real test with a live nuclear warhead. This test would either confirm that America had developed an unstoppable nuclear weapon system or reveal serious problems that needed to be fixed. At 12:30 p.m. Pacific Time on May 6, 1962, the USS Ethan Allen prepared to conduct an experiment that had never been attempted in human history. The nuclear-powered submarine sat submerged in the Pacific Ocean at coordinates 12 degrees, 26 minutes, 53 seconds north, 134 degrees, 51 minutes, 14 seconds west, approximately 1,200 miles southwest of California. The crew members knew they were about to make history, but they had no guarantee that their mission would succeed. They were preparing to fire a live nuclear warhead from underwater for the first time ever. The submarine's crew had spent months preparing for this moment. The Polaris A-2 missile loaded in their launch tube contained a W-47Y-1 nuclear warhead with a yield of 600 kilotons. This was not a dummy warhead or a simulation. It was a real thermonuclear weapon designed to destroy entire cities. The missile's target area was located 930 kilometers northeast of Kiritimati Island, in the middle of the empty Pacific Ocean, where the nuclear explosion wouldn't harm anyone.
Technological efficiency also scored high in the fusing and firing systems and in the device telemetry. The series also yielded important new weapons effects information.
The solid fuel rocket motor ignited properly, sending the missile climbing rapidly toward its target area. Military observers on ships and aircraft positioned throughout the Pacific tracked the missile's flight path using radar and optical instruments. The missile flew through the atmosphere carrying its 600 kiloton nuclear payload toward the coordinates 4 degrees 49 minutes 59 seconds north, 149 degrees 25 minutes 1 second west. The warhead had already survived the violent submarine launch and the transition from water to air. Now it faced the stresses of high-altitude flight as the missile arced through space toward its target. Everything depended on what would happen when the missile reached its target area. The nuclear warhead contained precise timing circuits, radioactive materials, and explosive components that all had to work together perfectly to create a nuclear explosion. If any part of the system failed, the test would be a complete failure, and the Polaris program would face serious questions about its reliability. The missile reached its target area, and the nuclear warhead detonated exactly as planned at an altitude of 2,530 meters above the Pacific Ocean. The explosion created a massive fireball that rose thousands of feet above the ocean's surface. The blast produced a yield of 600 kilotons, confirming that the W-47Y-1 warhead had functioned properly despite the stresses of submarine launch. Military observers recorded the explosion using high-speed cameras and scientific instruments positioned throughout the test area. Shot frigate Bird had succeeded completely. The United States had proven that nuclear weapons could be launched from submarines and would detonate reliably at their targets. America now possessed a nuclear strike capability that was virtually undetectable and unstoppable. The test established that America's nuclear deterrent could survive even if all land-based weapons were destroyed in a surprise attack. But the full implications of this successful test would take time to understand. Military experts considered shot frigate Bird more significant than nuclear tests with much larger explosions because it proved something far more important than raw destructive power. The successful test demonstrated that nuclear submarines could strike any target on Earth without being detected or intercepted by enemy forces. This capability represented a complete shift in how nuclear weapons could be used in warfare. The nuclear balance of power changed fundamentally because submarines were nearly impossible to track in 1962. Ocean detection technology at that time was rudimentary, making submarines truly undetectable once they submerged beneath the surface of the world's seas. Unlike bombers and silos, which show up on radar or satellite, submarines could disappear, guaranteeing a retaliatory strike. This invisibility meant that countries couldn't predict where submarine-launched nuclear attacks might come from. Submarine-launched nuclear weapons were virtually unstoppable once fired. The submarines could position themselves anywhere in the world's oceans before launching their missiles. Enemy forces had no way to predict when or where these attacks might come from. Even if enemies knew that nuclear submarines were somewhere in the area, the vast size of the oceans made it impossible to find and destroy them before they could launch their weapons. The test proved that America could maintain a nuclear deterrent even if all its land-based weapons were destroyed in a surprise attack. Previous nuclear strategy assumed that countries needed bombers and land-based missiles to threaten their enemies with nuclear retaliation. Shot frigate Bird showed that submarines alone could provide enough nuclear firepower to destroy any country that launched a first strike against America. Each Polaris submarine carried 16 warheads of 600 kilotons each, giving a single submarine the power to devastate multiple cities. Military strategists realized that nuclear submarines created a permanent second strike capability that guaranteed retaliation against any aggressor. The concept of second strike capability became central to nuclear planning during the Cold War. Countries needed to know that they could strike back even after suffering a massive nuclear attack. Submarines provided this capability because they were so difficult to locate and destroy. The Soviet Union now had to assume that any nuclear attack on America would result in devastating submarine-launched retaliation. Soviet military planners couldn't count on destroying all of America's nuclear weapons in a surprise attack because they had no way to locate and sink all American nuclear submarines. This uncertainty made nuclear attacks much less attractive to Soviet leaders because they couldn't guarantee avoiding massive retaliation. Shot frigate Bird established the foundation of modern nuclear deterrence doctrine based on assured destruction capability. The test proved that nuclear weapons launched from submarines would work reliably in actual combat conditions. This reliability meant that countries could base their entire nuclear strategy on submarine-launched weapons. The doctrine of mutually assured destruction relied on the certainty that nuclear attacks would always result in unacceptable retaliation. The test fundamentally proved that nuclear war had become unwinnable because submarine-launched retaliation was guaranteed and unstoppable. Any country that started a nuclear war would face certain destruction from submarine-launched nuclear weapons that they couldn't prevent or intercept. This reality changed how world leaders thought about nuclear weapons and international conflicts. Nuclear weapons became tools for preventing war rather than fighting it, because using them guaranteed mutual destruction. The success of Shot frigate Bird created a nuclear stalemate that would define global politics for generations. But countries had become worried about the health effects of radiation spreading through the atmosphere from nuclear explosions. Because the treaty banned underwater tests, Shot frigate Bird stands alone as history's only full-scale live SLBM warhead trial. The treaty effectively ended the era of large-scale atmospheric nuclear testing. It's a stark reminder that the deadliest weapon is the one you never see coming, hidden beneath the waves. What surprised you most about Shot frigate Bird? Let me know in the comments below. If you want to follow the story of the Gerboise Bleu, check out our video here.